In this lesson, you'll learn to write equations of circles and graph circles. Why are circles important in air traffic control? Radar equipment can be used to detect and locate objects that are too far away to be seen by the human eye. The radar systems at major airports can typically detect and track aircraft up to 45 to 75 miles in any direction from the airport. The boundary of the region that a radar system can monitor can be modeled by a circle. A circle is a set of all points in a plane that are equidistant from a given point in the plane called the center. Any segment whose endpoints are the center and a point on the circle is a radius of the circle. Assume that x, y are coordinates of a point on the circle at the right. The center is at hk, and the radius is r. You can find the equation of the circle by using the distance formula. So we have the difference in the x's squared plus the difference in the y's squared equals square root of equals d squared. In this case, d, the distance we're talking about, is the radius, and they let one of the points be hk. So we have x minus h squared plus y minus k squared, and if we square both sides, equals r squared. And that is how we can generate the formula for the equation of a circle. The plan for a park puts the center of a circular pond of radius 0.6 miles, 2.5 miles east, and 3.8 miles south of the park headquarters. Write an equation to represent the border of the pond using the headquarters as the origin. Okay, we usually go right when we're talking about east, so there's our x value is 2.5, and south we would go down, so negative 3.8 is my y value, and the radius they said was 0.6, so we can just plug into the formula. So we've got x minus 2.5, y minus negative 3.8, so we're going to put plus 3.8, equals r squared, so 0.6 squared. And the only thing they simplify is 0.6 squared is 0.36, and that is our equation. Now that was a pretty simple plug, not even really chug, because the only thing we had to do was square the radius. So this time they're going to have us do a little more work. Write an equation of the circle if the endpoints of the diameter are at 2, 8 and 2, negative 2. So the first thing we need to use is the midpoint formula. And all we do for the midpoint formula is add our x's together, divide by 2, and add our y's together, and divide by 2. So the midpoint is going to be 4 divided by 2 is 2, and 6 divided by 2 is 3. Then we're going to have to use the distance formula to find the radius. So difference in our x's, oh that's lovely, 2 minus 2 if we just use that first point, squared plus the difference in our y's, and the square root of that. So 2 minus 2 is 0. 0 squared is still 0. 8 minus 3 is 5. So 5 squared is 25. Square root of 25 is 5. But we may as well have left it as r squared, because in the center of the circle we have x minus h, which we found was 2 squared, plus y minus k we found was 3 squared, equals r squared, so 25. Okay, so far both of those problems we had done in geometry. The next one is going to be something new to this book, but it uses the definition of tangent that we had from geometry. A line in a plane of a circle can intersect the circle in 0, 1, or 2 points. A line that intersects the circle in exactly 1 point is said to be tangent to the circle. The line and the circle are tangent to each other at this point. Write an equation for a circle with center at 3, 5 that is tangent to the y-axis. Without graph paper this might be kind of tricky, but if we plot the point, 3 to the right, 5 up, and tangent means it touches at 1 point. So tangent to the y-axis, we have a radius then of 3. So with graph paper and remembering the definition of tangent, this wasn't a very big jump at all. So we have x minus the x part of our center, so x minus 3 squared plus y minus the y part of our center, 5 squared equals our radius that we found from the graph squared. So our final answer is going to be x minus 3 squared plus y minus 5 squared equals 9. You can use completing the square, symmetry, and transformations to help you graph circles. The equation x minus h squared plus y minus k squared equals r squared is obtained from the equation x squared plus y squared equals r squared by replacing x with x minus h and y with y minus k. So the graph of x minus h squared plus y minus k squared equals r squared is the graph of x squared plus y squared equals r squared translated h units to the right and k units up. Find the center and radius of the circle with an equation x squared plus y squared equals 16, then graph the circle. There are no constants next to either our x or our y, so our center is at the origin. And the square root of 16 is 4. And when I draw circles free-handed by myself, they do not look this pretty, but a good place to start is plotting your origin, and then from there we're going to go 4 units, up, down, right, left, and then hopefully, if you wanted to, you could grab a compass and draw a perfect circle, but otherwise we try to sketch one. Mine end up looking somewhat like potatoes a lot of the time. Now this is beyond the scope of what we tried in geometry, but we're ready for it now. We've been doing lots of completing the square. Find the center and radius of the circle with the equation x squared plus y squared plus 6x minus 7 equals 0, then graph the circle. So we've got x squared plus 6x plus some constant to complete the square, plus y squared, and I didn't need to complete the square there because there was no 6y or some constant times y, coefficient times y term, and I move the 7 to the other side. To complete our square, we take the coefficient of x divided by 2 and square it. So 3 squared is 9. So if I add 9 to one side, I need to add 9 to the other side to keep it balanced. So our completed square is going to be x plus 3. And remember where the 3 comes from, right here. Plus y squared equals 16. And we could rewrite that one step more so we can easily see the radius. So we have a circle with center at -3, 0 and radius 4. So once again, when I'm graphing by hand, I will plot the center, and from there I go 4 units, right, left, up, down, and then I do my best to draw a nice round circle. And as far as I know, almost every ACT test has one of these questions on here. So it's a good thing to keep in mind, not too hard to commit to memory. The equation of a circle with a center hk and radius r can be written in the form x minus h squared plus y minus k squared equals r squared.